So this video is about our exponent rules, both what they are and why they make sense. So our first rule is if I've got x to the a times x to the b, so I'm multiplying the same base, then I can add those exponents. So that makes x to the a plus b. Let's just see why that makes sense using an example. If I have x squared times x cubed, well, x squared is x times x. X cubed is 3 of those. So altogether, I have x to the 1, 2, 3, 4, 5. There's 5 x's altogether here, which is gotten by just adding the 2 and the 3, right? So if you have the same base and you're multiplying them, you're going to add those exponents. If you have the same base and you're dividing, so x to the a divided by x to the b, well, that simplifies to actually subtraction. So that makes x to the a minus b. You'll subtract the exponent on the bottom, so a minus b in that case. So let's say I have x to the 5 divided by x to the 2. Let's see why this makes sense. X to the 5 would be 5 x's. There they are, 5 of them. X to the 2 would be 2 x's. And I can simplify this by canceling stuff on the top from the bottom, right? So that x would cancel with that one, that x would cancel with that one, and I'm left with just 3 x's. So that would be x cubed, which I got by doing 5 minus 2. So that's why if you have the same base, x to the a divided by x to the b, you're doing division here, you'll subtract your exponents, x to the a minus b. Right, what if I have a power of a power? So x to the a to the power of b. Well, in that case, you multiply your exponents. That'll be x to the a times b. Why does that make sense? Let's say we've got x squared, and x squared is being cubed. Then x squared is 2 x's, right? And then the cube bit means that I'm going to have those 2 x's 3 times. So x times x, and another one. Oops, there's my x. How many x's are there altogether? Well, there's 1, 2, 3, 4, 5, 6 of them. In other words, x to the 6, which I got by multiplying the 2 times the 3. Let's go ahead and do x to the 0 next. X to the 0 is a really nice simple one. X to the 0 is just 1. Now, why is that the case? Let's actually use our division rule to understand it. Let's say you have, say, x cubed divided by x. Oops, sorry. X cubed. There we go. Well, one way to think about that would be using our division rule. That would be x to the 3 minus 3. Well, 3 minus 3, though, is just 0, so that makes x to the 0. But the other way to think about that would be just by canceling things that are the same. So I've got x cubed on the top, x cubed on the bottom. That's the same. If I cancel them, that would make 1. So what I've got left with here is that x to the 0 must be equal to just 1. So anything to the power of 0 will be 1. All right, let's go back and fill in our negative exponents now. So if you have x to the negative a, that makes 1 divided by x to the positive a. So you can keep the same exponent and put it in the denominator, make it 1 over x to the positive a. Or if this is a fraction here, I'll show you some examples soon where we'll actually flip our fraction, flip the denominator and the numerator, and make our exponent positive. Right, why does that make sense? Let's say we have an example of this here. Say we have 1 divided by x cubed. Well, using what we just said about 1 being x to the 0, that's the same as x to the 0 divided by x cubed, right? If 1 is x to the 0. And then, using our subtraction rule, x to the 0 divided by x to the 3 would be x to the 0 minus 3. Or in other words, x to the negative 3. So what you can see here is that x to the negative 3 is the same as x to the 1 over positive 3. All right, our last one, the nth root of x is x to the power of the fraction 1 divided by n. This one's a little bit trickier to understand, so I'll use numbers to maybe make a little more sense of it. Let's say you had 16 to the power of a half. Well, if I have 16 to the power of a half, that's going to mean, by this rule, the square root of 16, right, which is 4. But let's see why that's the case. If I have 16 to the power of a half times 16 to the power of a half again, using my addition rule, x to the a times x to the b is x to the a plus b, this would make 16 to the half plus a half, which is 16 to the power of 1. In other words, this 16 to the power of a half times itself, 16 to the power of a half, gives me just 16. Well, what times itself twice gives me 16? That number must be 4, or the square root of 16. So that means that this must have been a 4, and this must have been a 4. Or in other words, that is the square root of 16. We could do this with, I'll show you another example so you can see how it works with a cube root. Just clear up some space for us here. Let's say you have 27 to the power of a third. And we did that 3 times. So 27 to the power of a third times 27 to the power of the third. Then what would that give me? It would give me 27 to the third plus a third plus a third. That makes 27 to the power of just 1, or 27. Well, what times itself 3 times is 27? That number here must be the number 3, or in other words, that is the cube root of 27, the number that when you multiply it by itself 3 times, you get back 27. All right, so that is our rules. Next, we'll be doing some examples of how those rules work.